Alright, Logic fans, welcome to our second video on section 3.3. This is video 3.3b, and we're continuing our discussion of rules of replacement. We were focused on the rule assoc, which I still have up here, and remember, it goes both directions. You can move the parentheses to the you can shift them left and you can shift them right, and you can do it for ors as well as for ands, okay? So, by way of making explicit perhaps some things that you might sort of intuitively miss about what assoc allows you to do and what it does not allow you to do, let's play a game of permissible or impermissible. So what does Ash's rule let you do and what does it not allow you to do? In each of these cases, there's 1, 2, 3, 4, 5 of them, okay? Assoc has been applied from the number 1 to the conclusion C, okay? And the question that I have for you is, in each of these cases, is the association application permissible or impermissible? Pause now. Okay, hopefully you've had a chance to pause and think about this, but let's run through these together. So, in this case, this is absolutely permissible. You can go from this string to this string, no problem. That's exactly the kind of thing it allows, okay? So in this case, we shifted the parentheses to the right, okay? So it was sort of like this one, but with the ors. That's absolutely fine. Now, what about in this case? So we've got the ands, and the parentheses are sort of to the left, and we shift them to the right. Can you do that? Yes, absolutely. This is permissible. You can absolutely do this, and that is just an exact instance of this particular rule. All right. Now it gets a little bit more complicated, okay? So let's take a look at this example right here. Let's see here. So what happened? Okay, this is absolutely permissible. You can do this. This is okay. Now notice the main connective is the or here, but it doesn't matter. Assoc is a rule of replacement, so we can go inside of this sentence and look at just this part of it, okay? And we can start screwing around with that using our various rules of replacement. In this case, we're going to use assoc to shift the parentheses over like so. And this is absolutely okay. So it has that power. All right, so it doesn't matter that you've got this a or thing over here. Up here, it was sort of like, you know, across the whole thing. But here, we're sort of just clearly inside of a sentence screwing around with it. And it's a rule of replacement and therefore can, in fact, do that. What about this case over here? Let's take a look. All right, this is also allowed. This is permissible, okay? So this is why I do this. It can get a little bit confusing, but just picture this whole thing as P, right? If this whole thing is P, then you've got P or, in parentheses, Q or R. And so we can just shift it to get P or Q all by itself, or R, okay? And that's exactly the kind of thing we did. So that was an application of shifting the parentheses sort of from the right to the left. So it was like this case, okay, but with ors. All right, let's look at our final example here. Is this allowed or not allowed? Permissible or impermissible? Okay or forbidden? Okay, this is forbidden. Do not do this. This is criminal, not allowed. Assoc does not allow you to do this. Basically what happened here is the person wanted to move the parentheses across an arrow, and you can't do that, okay? It has to be the two ands or the two ors and not a combination of the ands and ors. We will have a different rule that we discuss later today called distribution, which handles cases where you have like a P with an and then a Q or R. So we'll talk about that later, but nothing like this with the if-then, okay? That's absolutely prohibited. So they were all permissible except for this last one, which was forbidden, and I hope that helps clarify some of the types of things you can look for and what the true powers of association are. By way of getting you some extra practice with association as well as combining it with Comm, which is a common problem-solving technique, here's a little problem for you to figure out. So given this string, syntactically deduce this string. Pause now. Okay, so here's how I did it. Now that you can do these in a different order potentially, and it would still be a perfectly fine syntactic deduction. So you start with this string, right? And then the basic strategy that I had was, since we were trying to get to D, is isolate the D by itself and get it all the way by itself on the far left so that I could then simp it out as I've done here, okay? And there were different ways of accomplishing that, but the first thing I did was I applied a SOS across here, and notice what my values of P, Q, and R are in this particular case, right? So basically I grouped this as P and C, right? So P and Q in one thing, and then and D, and now the D is isolated. Then I comm'd it so that it was in the left position so that I could apply simp. And this is a very common thing, and it's probably worth trying as an exercise. Using a SOS and comm and simp, right, from this sentence, you can get every single one of these A, B, C, and D by itself. Like here we got D by itself. You can also get B by itself. You can also get A by itself. You can also get C by itself. And it's worth trying that as an exercise to reinforce the sort of combinatorial play and interaction between a SOS, comm, and simp. Okay, let's move on to another rule of replacement for ands, ors, and nots. And this one is a lot of fun, and computer scientists will definitely be familiar with it. Okay, and that is DeMorgan's, all right, which we abbreviate DEM, all right? So this looks pretty complex, but once again, like a SOS, it's got these 4 parts, but they're pretty easy to recognize in a patterned way. So let's just start with the first one, and the others follow very naturally just from this one. So let's suppose you've got a conjunction negated, and that's like a given. What you can do is you can distribute the negation through, like you would in mathematics, onto the P and onto the Q, provided you switch the and to an or. Okay? And so this is really interesting. And if you think about it in ordinary English, this is interesting. So like if you cheat and you allow yourself to think about it semantically for a second, right, you'll see that this line is saying it's not the case that this conjunction is true. It's not the case that both P and Q. Therefore, either P is false or Q is false. Either P is not, at least one of these is false, P or Q, right? And so you can kind of get yourself to see that. What's interesting here is that you can also go the opposite direction. You can go from this as a given to this, and that's what I'm saying here. So that's pretty easy. You can go both directions. You can go from not the case that this conjunction to at least one of the sort of, conjuncts is false here, and you can go from at least one of these is false to it's not the case that they're both true, right? So you can go either way. And then all I'm doing over here is I'm saying, oh, and by the way, if this had been an or, you can do a very similar thing, and again, it works both directions. So for these two, it's not the case that this disjunction is true. It's not the case that either P or Q, therefore both P and Q are false. P is false and Q is false, right? Similarly, if you've got P is false and Q is false, if that's your given, if this were your given, then you can say it's not the case that P or Q. And so that's the sort of informal, intuitive rationale for DeMorgan's, and this is a very common rule that is employed widely in any kind of reasoning endeavor, so it pays to be familiar with it. And we're going to take a little bit of time to go through it and make sure you understand some of its nuances. So once again, I'm going to take these off the board. But just remember, you know, if this was an or and this was an and, you can do that as well, okay? And let's look at an actual example here. So in this case, let's play a game of permissible or impermissible, allowed or forbidden, okay? Let's try each of these. In each of these cases, there's 6 of them. Okay, here's a case, here's a case, here's a case. DeMorgan's has been applied, and the question is whether or not that application of DeMorgan's is permissible or impermissible. So take a second to run through these, and we'll come back to do them together. Pause now. All right, let's go ahead and go through these. Hopefully you've had a chance to get them, but this is absolutely permissible. Okay, this is a standard use of DeMorgan's, and it's one you should start to recognize readily. Okay, let's take a look at this one. This is absolutely impermissible, not allowed, and hopefully you were able to identify the mistake. The mistake is that this or was not switched to an and. Okay, And by the way, one little hint when you're wondering, does a rule allow me to do something or not? Like, let's suppose you forgot, you're trying to remember, wait, can I make this maneuver or not with this rule? You can cheat a little bit and ask yourself about it semantically. So from it's not the case that A or it's not the case that B, does it follow it's not the case that either A or B? And if you have to, you can run a truth table and you will find out that no. Like, let's suppose that A is false and B is true. Okay? If A is false and B is true, then this is true, right? But this is false. And so that's a case where you've got a true premise and a false conclusion, and therefore this inference will not be allowed by our syntactic rules. So I'm a god that's laid down these rules correctly, hopefully, okay? And so you want to make sure that you can test things that way if you have to, and it's a useful trick. So this is absolutely impermissible, forbidden, do not do it. Okay, let's take a look at this case, and here we start to get into some of the more interesting applications. This is allowed. This is perfectly permissible. Okay, notice in this case, your Q is not B. Your A is P. Sorry, your P is just A by itself. Okay, and your Q is just not B. So this is of the form not P and not Q. Right? And then you just apply it accordingly, all right? I'm just following the rule here. So the application we're imagining is this one, where this is like this, and this is like this, okay? P and, excuse me, not Q and P or Q, like that, okay? So this is the application of it that we're imagining that was taken off the board here, but that's absolutely allowed, okay? So be on the lookout for stuff like that. All right, let's take a look at this one. It's not the case that A and B, okay, you cannot apply DeMorgan's here. The reason why is that DeMorgan's requires you to have the not. There's no not here. And so your starting thing has to have the not on either side of a conjunction or a disjunction. Okay, so this is absolutely not allowed, and it's not allowed for that reason. Okay, now you might be thinking, well, but surely, Ash, this follows from this, and it may or may not, but the syntactic rule doesn't allow it. So when I was talking about up here, you can look at this and say, oh, this is not allowed because it doesn't follow. That's fine, but just because it does, it doesn't automatically. It does follow. This sentence does follow from this sentence. Just because that happens doesn't mean the rule allows it. Okay, so you got to be a little careful there, and I want to make that explicit point to you. So this is prohibited, not allowed. Okay, you have to have the not be there, and there's no not. Now that might lead you to think, oh, what if I added a double negation? Then could I do this? And yeah, absolutely. And notice that's that case there. So you might have to do a double negation first, and that's totally fine. But the question here is can I go from this to this directly using only the rule DeMorgan's? And the answer to that specific question is no, you may not. Okay, let's take a look at this one. This is absolutely allowed, no problem. Oh wait, I repeated these. I'm sorry. Let me take a look here. I apologize for that repeat, but I've switched them here. So pause now and take a look at these two. We're going to do a couple others. We're running low on time, but we'll finish these two right now. Okay, so what we're going to do here is, you're going to distribute it through, and when you distribute it through, this is what you get. Okay, you get not A or not B. So this whole thing here is P in this, or is Q in this case, and this whole thing is P. Right, so it's not the case that parentheses P and Q. So Q takes this whole value, which means that's Q right there. Okay? And a very similar thing shows you that this is incorrect here. So let me spill that into the next video. Look for 3.3c. We'll catch you on that one.